Hey, hello there, and welcome back for more Advent of Code. So, I am a bit behind schedule on Advent of Code. I think the last one I did was day 17, wasn't it? Yeah, 17. The one about the lava pathfinding, and which I also didn't record the video, but I recorded some refactoring. By the way, like previous video from that was the one that got all messed up by OBS, so I'm in a rough streak, I think, but well, let's try to see what's next and hopefully catch up or not get so far behind. Alright, so day 18, Lavaduct Lagoon. Thanks to your efforts, the machine parts factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of part requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. Look at these inputs. Is this like hex codes? And the first things look like directions, like right, down, left. However, they are unsure the lagoon will be big enough. They've asked you to take a look at the dig plan, your puzzle input, for example, this thing. The digger starts in a 1 meter cube hole in the ground. Then they dig, will this be a 3D puzzle? Then they dig the specified amount of meters up, down, left or right, clearing full 1 meter cubes as they go. The directions are given as seen from the above, so if up were north, then right would be east, and so on. Okay, thanks. Those coordinates make more sense to me than north, south, and so on. Each trench is also listed with the color that the edge of the trench should be painted as an RGB hexadecimal color code. Okay, wow, these are colors. That's new in Advent of Code. Or I don't remember actually. Ooh, pretty. What's this grid? When viewed from above, the above example dig plan would result in the following loop of trench. Okay, trenches. So I guess you start, where is this starting? In the top left, as usual, like right 6, 1, 2, 3, 4, 5, 6. Okay, seems that way. Down 5, and so on. Okay, so this, yeah, they are not like relative coordinates, like turn left or right from where you are pointing, but like absolute coordinates, which I think makes things easier. Okay, sure, so you make a loop of a trench. At this point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior, so that is 1 meter deep as well. Now the lagoon can contain a much more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. What? The edges are also painted according to the color codes in the dig plan. Okay. The elves are concerned the lagoon won't be large enough. If they follow the dig plan, how many cubic meters of lava could it hold? Okay. So should we do fluid filling again for this? I think so. One thing that I'm like, these color codes are just mentioned but not used for part 1, right? Like where is color mentioned? While the interior is dug out, the edges are also painted according to the color codes in the dig plan. So I sort of would like to do some visualization of this and see what if these colors are something, you know, make an image or something. Let's also take a look at the inputs, which okay, so the inputs, it's a longer file, of course, but these coordinates are not huge. Like the movements in each coordinates are not in the millions. So that's nice. I guess we won't need to worry about like clever optimizations, at least for part 1. This is the cat. My cat is jumping around. So sorry if today's video is a bit unfocused, because I am, well, it's a bit late already, and today I haven't been very, like I've been a bit distracted, let's say. So let's see if I still have the neuron activity to be able to do so, or brain cell. Are brain cells also called neurons? Neural network, yeah. Yeah, if I'm still awake enough for this. So yeah, I'm thinking of like doing this on a grid, although it doesn't say in any anywhere that you start on the top left. Yeah, and actually the real input is starting like going 7 to the left. So if you started on the if you made a grid and you started going to the left, you will immediately go out of bounds. This could also be fixed by using like a torus, like a circular grid, that if you go to the left, you appear on the right, and you make it as big as possible to hold whatever input you're passed. But also another idea, like there's definitely different ways that this could be solved. So for counting, I'm thinking about doing flute filling, but I have to confess, I think that this is the problem. Yeah, this is probably the problem that a friend of mine spoiled me a little bit. He mentioned some algebra theorem that was called like shoelace or something like that. Shoelace and pick. Is this what I've searched for this? If I can. Shoelace pick theorem. Shoelace formula. So okay, there's different things, shoelace formula and Pick's theorem. I don't know which one my friend was talking about, but I think he used some of this algebra thing to probably to count the area, because this is basically I don't know if it's this one, but I think it is. It's a thing that allows you to compute the algebra of a polygon that has like integer coordinates basically on the vertices. So maybe I could read this and understand. And this thing, it's a simple polygon with integer vertex coordinates in terms of the number of integer points within it and on its boundary. Yeah, but I think this is like too general for what we need to do here, because we don't have any diagonal lines or anything. Well, so far, maybe in part 2 there will be. Maybe I got too spoiled. but yeah, and also in here you have to know. Yeah, so you have to know all of these points. You have to know the points that are inside the polygon. So that doesn't make sense for our case, because if you know the points inside, well, you already know you count them, and you know the area, because everything is square. So I don't think it's this what would help us, but maybe this one is. But I don't know. I'm more tempted to go for a simple fluid filling, or I don't know if simple, but a known solution to me, which is fluid filling. Okay, let's jump into the code and stop talking a little bit. So okay. Let's copy our templates as usual. This is day 18. What was the name? Lavaduct Lagoon. And this is taking so long when it's starting. I don't know if it is Rust Analyzer or VS Code or what. Lavaduct Lagoon. Lagoon is with double O? Yeah. That's not a word that I'm used to. Let's copy the templates. Day 18. Oh, already day 18. We already have quite a few stars. That's nice. Our sample input will be this. And the output that we expect here is 62. Okay, and the real input is this. I wonder what the colors will be used for in part 2, I guess. Sorry, just a second. And I'm back. I don't know if it gets caught on the microphone, but my cat sometimes like scratches the door for me to open them. So if I don't do it, she keeps doing that, and well, it's effective because it always makes me open the doors for her. Okay, so one thing that I'm wondering is if this input actually draws something interesting. So I definitely would like to see what this thing draws on the terminal. And well, let's think a little bit about how to model this, because a grid, even though I'm very used to and I like doing things with 2D grids, might be a bit like more complicated for this, because we don't know how large the grid should be, basically, and where should we start on the grid drawing things. So to solve that, well, there's different things that you could do. One thing could be to make a very large grid, I don't know, like whatever, 10,000 by 10,000, and start in the middle and like hope for the best. Hope that you don't go outside, which is totally acceptable, I guess, for something like this. Another thing that you could do is to have a dynamically sized grid, so that you can pass also like negative coordinates to it, so you don't have to care about accessing negative indices. The thing, could just grow and move things around, like reallocate the memory. But that's also like too much complexity, I think. And I think the simplest thing, non-horrible thing, but because having a giant grid and starting in the middle, I think is a bit horrible. But the simplest thing that is not so horrible, I think, could be to do 2 passes on these inputs. Like the first pass, you collect basically go walking following these directions, and you collect the minimum and maximum of each coordinate, and then you make a grid that can hold that width and that height, and you start on the offset so that the minimum coordinate doesn't go negative, like to the top or to the left. I feel a bit tempted to try that, or there is another alternative, which is to not use a grid at all and use another data structure, like for example a hash map or a hash set or something like that, like a bag of things, and you'll just start at 0, 0 and then walk and push things into, well, a collection. It could also be a vector, I guess, but with a hash map or a hash set you would have direct access to those things, which would be useful if you then need to do fluid filling. So those are the options, I guess. I'll try to go with the hash map or hash set and see how it goes. Try to get an answer and see what part 2 is about. So, okay. Where do we start? Well, we should, I think, parse this thing. Yeah, it's been a while since I've actually parsed something, so let's parse. And actually the input here, like the actual input, I thought I saw things aligned, but no, they are not aligned. There's just a single space. Okay, but let's do the usual thing. Let's say, what are these instructions, I guess? Dig plan. Yeah, let's call this instructions, and the whole thing, well, we can call the whole thing dig plan, which would be, this can be a vector, no problem. Sure. We're gonna go as usual, input lines, then map to a function called, let's say, parse instruction, I guess. It could be called like parse dig plan instruction, but let's say parse instruction on this line, and then try collect, because let's make this thing fallible or fallible. I don't know how to pronounce that. Generate this, please. And this thing will return an AOC dynamic result of an instruction. And what is an instruction then? Well, it's gonna be, is it an enum? No, it's not an enum, it's just a, what is this thing? I mean, the enums are basically the directions, I guess. So then it comes just a number and then a hex color, but the hex color we're not using for anything. So let's just say we're gonna have an enum direction like we sometimes do, and this is up, down, left, and right, usual at this point. And let's say that, let's not model instructions in any clever way yet. Let's just say this is gonna be a direction and a number, and I guess all the numbers are positive, right? Looks like it wouldn't make sense to have negative. Well, yeah, positive. Okay, pass instruction. This is parameter, and what are we going to do here? Well, we could start by splitting this by white space, I guess. Split white space, and this is gonna be, we can collect these things into a vector. I guess I could use collect vec here from, let's see if I do everything at once, how awful it looks. So I want to like do that and also say, hey, let's and destructure this thing, like use a slice here and destructure this into what's this? The direction, the data specified meters. Yes, the number. Just call it number. I don't know. So there num and hex color, which the hex color we're not going to use, but we are just going to leave it there. So we collect this into a vec and call magic into it, try into, to try to convert the vector into a slice of size 3. So something like that. Do you like it? Not as much as my cat would like to be on my lap, but I kind of refuse her. And your problem here is, yes, I know this problem already. The thing is that the try into for vectors into like slices or arrays, I guess, is that they don't give you an error, like they give you back a result, like try into gives you a result, but of well, here is the signature, like the general signature, but this result has, well, will have a vector in the, an array, sorry, in the successful case, but in when it is not successful, it will give you an error with the vector itself, which is not very useful, in my opinion, but for some reason it does that. And since that vector is not an error, like doesn't implement the error trait, you cannot like propagate it up with the question mark operator. So the answer is to just slice the whole thing and then it should work. So this line is working. Now it's complaining that it's not returning an instruction yet. So okay, let's then say that the let's say let direction, like the actual direction, is gonna be match this parsed direction, and this is a string, right? So we're gonna just say up. It's gonna be direction up. Yeah, right. Something. Then down, left, and left and right. All right. And we're going to return just okie dokie of direction and this number, which we're just going to parse. Because num here should be a string slice, shouldn't it? If we do this, would you be happy? The dir here. Okay. So he wants me to dereference once here. Is that your thing, or should I dereference over here? Yeah, okay. And now it's complaining about the non-exhaustive match, and that is correct. We're just going to return an error with, we can format this and be helpful. So let's say an unexpected direction there. And we propagate this up. Great. And it wants me to inline this thing as usual. Yeah. Okay, I think we have parsed the big plan. We can print it probably. I mean, if at this point I don't know how to parse things, simple things, I should probably quit Rust or programming altogether. But we can run this thing. Cargo run. This is going to be the binary day 18 this time. And inputs 18 sample. Write 6, down 5, and so on. Yeah, it looks fine. Okay, great. Great. Now, to follow this plan, what should I do? Pushing things just in a hash set seems like a simple idea. And then we can, then I want to print them. So, let's do that. Let's do that. So we are going to, go over each of these. We're sort of going to draw on a set of points. So how are we going to do this? You're going to need a position. This could probably be implemented with a fold or something like that. But that doesn't make any sense because you need an accumulator. Yeah, let's just do a good old for loop. So for instruction in a dig plan, we can iterate it. What are we going to do? We are going to start at a given position. So let's say position be, well, we could just have the two variables, right? Xi, xy, sorry. These are mutable things. We're going to be changing this thing and pushing this into how this is called a trench, right? Like what we are digging a trench. So let's say that let also mute trench is going to be a hash set. Okay. And we are starting at this position, which I guess we should already push in the hash set. So we can say from iter, I guess, and pass xy already here, or something like that. Okay, so then we are going to have an instruction. Well, we can actually like the structure here, and the instruction is going to have a direction and a count. I don't know, here I call this thing num, but I think count is a little bit of a better word. And we are going to, I guess we can map this direction enum into like we can just loop here and say for in like from 0 to count, we are going to take this amount of steps, and inside of here we can do the match of there. And well, you can help me. Yes. If if we're going up, we're gonna do x, y minus equal 1. If you're going down, we're gonna do this plus equals 1. If we are going left, is same idea, and right, same idea, but for the x coordinates. Great. And here you're complaining because expected integer. Yeah, I guess I can dereference you here, or I can just consume you and not worry about you. Okay, so we walk 1 in this given direction, and then we should push this into the trench. Yeah, trench insert xy. Okay, and your problem here is that probably the return. Yeah, okay. Type annotation needed for hash sets. Consider giving trench an explicit type. What are the type? Why do you need a type for these? That's weird. Like, oh, look at that. There it didn't need. Oh, but it's taking reference, which is not great. But it's weird that you need type annotations for that, you know? Like, yeah, sure, have them, but I'm not happy about that. It's like dumb repetition. I can put this on a turbofish, I guess. What did I copy? I wanted to copy that. Can I put it in here? It's not like it's much better, but oh wait, no, there is a slightly better way of not repeating myself so much. We can do these into iter. Into iter collect. I mean, it works. I don't know if it's much better than calling like from iter. No, you know what? I do prefer the from iter call. Like, yeah, explicit type annotations for this is a bit ugly in my opinion, but anyway. Let's roll with this. So with this, we should have already like dug up the trench. In fact, if here we print the trench size, length, it should be something that the instructions tell us, description tell us about. Respect over 62, but if we do this at this point, yeah, 38. Is this 38? Yes, okay. So I guess we have dug up this trench. Now, I would also like to keep like count of what is the minimum and maximum x and the minimum and maximum y to draw these things. And I really want to do this to have an idea of what the actual input, like what's the shape of this input, like if, you know, if there's any hidden thing or something there. Oh, I forgot to to put a stopwatch, that's which I usually do, but I think I started at 0, so it's 43 minutes. Anyway, let's do that. Let's say also this is gonna be mute. I guess this is gonna be just a bunch of variables. So let's say mute min x, min y. No, I guess yeah, it just doesn't matter. Min x and min y is gonna be 0, 0, which is where we are starting, and well, actually the maximums is also going to be that, right? So you can say that, and then very uglily update those things. So we can say, okay, min x is gonna be this, like the minimum of this and the current x, and I guess we can say maxes is, well, same thing but the maximum, and then we can have all of this repeated but for y, right? Such a beautiful code. But we should have that done, and maybe we can print these things. So let's say x will go from and well, we can print this actually, min x and min y. No, min x and max x. And then y is going to go from min y and let's put a comma here, max y. Okay. Let's run this. 6 and 9. Nice. And we can also run it with actual inputs. Negative, oh, it was 0, 6 and 0, 9. Okay, and here it is negative 161, 213, negative 464. Okay. And could we draw this? I think we should be able to pretty easily, I think. So we're gonna go, I think. Yeah, so the sizes here, they are not so freakishly big. Like x is a total of like almost 400 wide, and this is also like 400 and something, or almost 500 tall. So it's a bit big, but not too much. We can simply iterate these things, I guess. So from y going from min y up to and including max y, and then for x in min x up to and including max x, we're going to make lines. So let's mute line. It's going to be a new string. And here I'm just going to say what? Basically, yeah, let's say let's character. It's gonna be, or even like line push, and I'm just going to push either dots or hash depending on if it is on the trench. So trench contains, if it contains this xy, and I'm sure you're gonna need a reference for that, then if it contains, draw the trench with this, or else I guess we don't even need a dot, we can use a space. Let's put a dot just to see the borders of things. And that's it for the line. We can then print this line. Okay. What if we run now? I'm going to run it on this console. Let's actually maybe copy this, which I don't know how to do with the keyboard. Well, it is a bit big, but if we... Ooh! It is a shape. Ooh, look at this shape. It almost... I got surprised. It almost looked like a country or something. like the shape of a country. So yeah, look at that. It's really, really pretty. I don't see anything like particularly weird about this. It's like everything, you know, there's no like closed loop or these things touching at any point or something like that would make fluid filling probably not work. Yeah, this is pretty nice, I think. The 0, 0 position, I've no idea where it is, so maybe I want to print that with a different character. And maybe find it on this mess. So let's actually say push the, does this contain, it's gonna be this, what if I write if the if xy is 0, 0, I want to see where the starting is, then write, I don't know what character I want there, but else if all of this. Yeah, the formatter didn't do such a bad job at this. I'm surprised. And Rust doesn't have a ternary operator, I think, and this actually looks nicer, I think. So what do I want for this? I want something that is visible. So Unicode block character block elements. Yes, this is what I want. Actually, give me this thing. And thanks Unicode for existing. If we run again with this, do we find that character, or should I also print it with a color? Where is this guy? Oh, there it is. There is this guy. Okay. So it's starting left and blah blah. I wanted to see where this thing is, because I would like to think of like how should we do the fluid filling. Basically we have two options, I think. Either start the fluid filling from the outside and fluid fill everything, and what hasn't been fluid filled would be the inside. Which is fine, but since we, like, the other option would be fluid filling from the inside, I think that would be even more natural in this case, because fluid filling would just be like pushing things into the trench and like forming the lagoon. And oh man, I'm so curious about the colors. Like, what do they mean? So the difficult thing about knowing like where to start fluid filling is like, okay, which coordinates do you start in? Like, what is a coordinate that is inside? And I think that's not so trivial to know. We actually did another puzzle this year that's where I used fluid filling for the pipe maze, and it wasn't really necessary, but you could do that with scan lines. But maybe I could use a scan line here and go left to right and see if across a single trench line, then I should be inside, I think. But if I find many, like if I'm just here on the zeroth line, I'm going to find like a row of many trenches, and this is kind of a problem because it means like I don't know when it ends. I don't know if I'm inside or not, because this could also have turned up here, and I don't know if I would have found it. So I guess, I mean, there's different alternatives, I guess, but an easy one would be to just hard code a point here. Like I know that in the point x0 and y minus 1 is going to be on the inside for the actual input, and therefore like do the float filling there. And I'm tempted to do just that. So let's actually leave this drawing here, right? And well, I'm going to leave it but commented. So we have the following of the directions, great, or the dig plan. Let's do the float fill now. So how are we going to do this? Let's actually, calling it float fill is it's like a bit weird because we are going to fill this lagoon or this giant trench with lava, and we are not filling with lava now. We are like digging it up. So let's say dig lagoon, or dig inside, or something like that. Because what would be another way of... Yeah, I cannot think of a very easy way of knowing if you are inside or outside right now. So I'm just going to ignore that. Dig out interior. Okay, yes. Dig interior. And we're going to just here pass the trench as a mutable reference, and the starting point, I guess, or just pass this, and this will know about the starting point. So generate this, dig interior, we can put it right here, below the types and above the parsing unnecessary code. Or like the parsing, I don't consider it very important. Okay, so this is the trench, sure. And what I will do is just hard code. Let's say, let's mute unvisited. Undug. Or to dig. Yeah, and this is going to be what? Like a vector. Just we can use a macro for this, and we are going to hard code what I know is on the interior. Very ugly, but let's leave a to-do comment here. The hard code starting interior points. Okay, I want to actually remember how I did the float filling for the float fill. Go to definition, call it unvisited, and I just popped things, compute the neighbors. You know what? I'm going to just take a little bit of inspiration from this. And visit it. So I'm just going to pop from here, push into here. I don't know what the expanded grid was. I'm just going to say, okay, to dig something is going to be pushing it into the trench. So trench, just insert XY. Then the neighbors, we don't need to do wrapping sub here. We can do better. We can just subtract because we are using signed integers, and yeah, we just that's makes things more easy instead of having easier than having a 2D grid. So neighbor tile, say this is not a neighbor tile, it's a neighbor cube. What are we asking here? We have the neighbors in each direction. Sure, we do have also a direction in them, but okay, we have the neighbors. Yeah, and here we were asking like if it was empty or something, and then. But what I'm going to do is like if it's not in the trench already. Yeah, if it is in the trench, it means like either we have dug it doing this digging of the interior, or that is the wall or like the trench that we have just dug in the beginning. So in either case, it's like we don't want to continue there. Yeah, we don't want to push that. So we just ask, we're just going to ask if the trench doesn't contain an X and Y, if it doesn't contain it, then we push this to be dug up next. Right? That kind of makes sense in my head. This thing wants a reference. We don't need any of this. Sure. Let's try it out. So we are going to be calling dig interior, and we can just print the same thing again to see if the interior of the lava lagoon, or soon to be lava lagoon, is dug. And it's running and it's not finishing, so this makes me think that I probably made a mistake and I'm going to be like running an infinite loop. So okay, I don't think that was so big that, you know, hashing wouldn't work. So do we see any, like if it doesn't contain this thing, then we're going to dig it, and then we just keep going, popping from here and putting this into the trench. So what's the problem? Let's say if the trench length, maybe I should just print the trench length and see how this thing is. Yeah, no, but that was gonna be slow at the beginning. Yeah, let's just do if the trench length is a multiple of, I don't know, 1,000, let's print it. You don't need parentheses for this, right? You can just ask this. We're gonna just print the trench length. Okay, just to have an idea of what's going on. And look at it go. This seems bigger than necessary, already at 1,000,000. So our fluid filling is overflowing the trench. I'm pretty sure, like we said, that it was like 500 times 500, that is what, 25 plus 4 zeros, that is 250,000, but we were into the million there, so we have some problem here, and it surely is some stupid thing. We are starting from 0x and -1 y, right? Let's actually, you know what? Let's just insert this here, like it's going to be the first one, and just cut out the rest of the loop. This should now not run forever, but I want to see, okay, yeah, we can see that, well, I can barely see this, and in the video it's probably not it's not really visible, but yeah, it's, believe me, maybe that like on top of the initial character there is another hash there, so it's starting from there. Okay, so let's do something stupid here and say, hey, if this is let's say more than 1,000, just break, just break, you know, like stop the fluid filling madness, and I just want to see what's happened there. We should be, I don't see anything new. What? Oh, because it's already more than 1,000, right? How long is at this point, before digging the interior? Yeah, let's just print the trench length, because of course this is the actual input now, not this input. 4,000. Okay, great. Now we're going to dig the interior and print the thing and say, okay, if it's more than 5,000, let's do a little bit of fluid filling. Like what will happen, not here because it's gonna be a mess. Let's print it here. Haha, look at that line, it's going straight out. So it's not caring about edges. So how is that? If I'm saying, like I am asking, if it doesn't contain this neighbor, we shouldn't push it for digging. That's weird. That's kind of weird, right? But isn't this one of the cases of, let me think, we're not pushing that, but I'm wondering if I should early terminate here. Say if the trench, this doesn't make sense to me, but let's ask if the trench already contains x, y, then continue. Ah, look at that. Now this looks more like fluid filling here. So what was the error then? Someone was pushing neighbors that were already in the trench? That doesn't make sense, right? If it's not in the trench, push to dig it. Although I don't understand which case we would be doing like this. On this line, we saw that it sort of went across this. So I'm quite confused. So yeah, quite confused. Like this seemed to have fixed it, but I don't understand what happened. So let's actually print line here and say digging, not diffing, digging x and y. Did I use like wrong variables or something? Don't see that either. Gonna be digging this, and let's dig the first ones and not print the giant lagoon. Run it here. Yeah, we keep going in the same direction there, so we don't need to print this much. We can go up to, I don't remember the numbers really, but will this print something? It's already printing too much. Is this okay? Okay, yeah, this is already going thus far. Digging this, it's inserting. Yeah, okay, yeah, no, we need to, right? No, but no, I don't understand it. The first neighbor that we push is y minus 1. So this is up. That's the next thing that we should be going for. Why are we going to the right also? Like the right is, oh, it's the last one that we push. So okay, yeah, this is a stack. So this is the first one that we pop. That's fine. Shouldn't make a difference, but we shouldn't push it if it's already in the grid, in the trench. So here we can see that, I don't know if I will be able to count it, but 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, I think so. It's going to start being like minus 1, 7 should be on the trench already. So this should be on the trench. Like let's ask this and say if it is, if the trench contains this thing, x, y reference. Okay. We run this, everything is false or false, but here we have some truths being printed. But why was it pushed to be dug? And x and y, like That's really weird. Well, we can say this, and here it's like, maybe we can do print line, pushing to dig NX and NY, New York. And I don't want to, let's remove like 100, 150 from this. So beautiful. What did I run? Oh, that was the sample. I actually meant the input. So again, go to 150. Today I'm being pretty sloppy, I know. Okay, so when we are up to like 6 minus 1, for example, 6 minus 1. Yeah, it's also pushing to dig 7 minus 1. We should be... What? What's going on there? Shouldn't 7 minus 1 be contained in the trench? We then ask when digging 7 minus 1, and it says true. What? I'm so confused, like, what's going on? Trench, do you contain this thing? Should say false in these things, in these cases. Seven minus 1, it's saying false, but when I'm digging, like the next thing that I pop to dig is 7 1, and I haven't pushed it on that trench yet, but it says it contains it. How? Like, how in hell is like, I am so confused right now. Oh, look at this. Wait. Oh no, this is so... Oh, the stupid error. This is NY. Damn, that was a typo. Oh man, what an idiot. Okay, okay. Let's, you know, if I would be coding with AI assistants, the AI would probably have called me an idiot there. So okay, this is running, but I want to have printing here. Oh, I run this in this terminal. That's not very useful. Okay, so now the fluid filling is looking a bit more promising. Yeah, it's filling in its preferred order, but that's great. We can keep going, I guess. We don't have to break in here. So let's fill everything it can, and now stop running things there. If we do this, oh, look at that, beautiful. It's now a filled lagoon. It's a weird shape also. How small can I make it? This is the shape, which looks like very organic, like a real thing. Okay. So now, actually, the length of the lagoon, if I'm not mistaken, should be the area. The length of this trench variable should be the answer for part 1, I think. So if we print line, and that is trench length, then we can run this with the actual inputs. And is this the correct answer for part 1, as messy as this was? Yes. Cool. Okay. I don't know if my brain is in like shape for doing part 2, but let's read what it is about. The elves were right to be concerned. The planned lagoon would be much too small. Oh, even with 70,000 cubic meters of lava. After a few minutes, someone realizes what happened. Someone swapped the color and instruction parameters when producing the dig pattern. They don't have time to fix the bug. One of them asks you if you can extract the correct instructions from the hexadecimal codes. Each hexadecimal code is 6 hexadecimal digits long. The first 5 hex digits encode the distance in meters, first 5, as a 5-digit hexadecimal number. The last hexadecimal digit encodes the direction to dig. 0 means R, 1 means D. Okay. Okay. So in the other example, the hexadecimal codes can be converted into true instructions. So this 0 means right? Yeah, okay. Right, down, left, up, clockwise directions. Okay, this is more interesting, I think. And now they are giant numbers. So our approach of fruit filling won't work. And I think my spoilage by my friend, hey, hello Gabriele, thanks for spoiling me. I doubt that you will be watching this, but now I understand why he implemented this. I guess this is what he implemented, the shoelace formula. So maybe today I will learn some maths. It's been a while. Yeah, digging out sorry, I haven't finished reading these instructions. Digging out this loop and its interior produces a lagoon that can hold an impressive this number cubic meters of lava. Convert the hexadecimal color codes into the correct instructions. If the elves follow this new dig plan, how many cubic meters of lava could the lagoon hold? It's so sad that these colors were for nothing. Like, do they even look like nice colors? Like, this is a mostly blue-green thingy. Yeah, maybe this is just gibberish. This is red and blue is magenta. This is a magenta thing, right? Wonder if it's, yeah, I doubt that, but maybe it's a good Easter egg that the creator could have put here. So I am a tiny bit tempted to try this out. If we printed the colors in the terminal, would we see them? Maybe we would if we print this before digging. If we print these things before digging, I am sort of tempted to do that and maybe continue with part 2 later on. I just want to see this in real colors. And by the way, can terminal escape code be used for printing colors? So print, say terminal print color with hex, or print hex color is what I want. Unpack. What is this? Oh, it's a Perl script. Beautiful. So background, blah, blah, blah. There surely is some escape. Here's the background with. Yeah, okay, so actually see this. Printf, blah. I don't know if fish has a printf. Probably it will. Beautiful. Oh, I screwed up. This is red background. Let's reset this. I think it is like this. No, 0. Beautiful. Let's just close this terminal and revive a new one. So what this printed, just the escape code, and then this as a string. So the /a is a bit like, I don't know what that is. Okay. Terminal hex color escape codes. This is probably what I want. Octal, Unicode, hexadecimal. Yeah, this is the prefix for the escape, sure. I think in Rust I had to use the octal, if I'm not mistaken. I'm not sure, or this one. Do we have hex colors? This would be what? Well, this is quite pretty. But this is like 8-bit colors. RGB colors. Oh, there is this. So I'm wondering, like, what is what I typed there in the printf thing. Four bits colors. Eight-bit colors. Okay. Combine this. All the colors. Yeah, I'm sure that this could be done. I'm just having like a sort of a brain fart trying to think about this. This is like 11 and then a color, and the /a, I don't know what that is. So let's look for closing this and then 11. No, not really. Let's write fonts, 11 colors, and do you appear here? 11. Yeah. Code shift. so many things that you can do on printing things to the terminal. It would be nice to know more about this. But yeah, this was setting the background, right? So can't we just do something like this? I will assume that this %s is just putting this inside of this. Actually, I can test this by not using the escape code and just this. What is this? Yeah. And what does the A do? I'm not sure what it does, but okay. So 11, like escape code 11 and the hex seems to kind of work. Isn't this registered here somehow? So looking for the cursor. How is this working? I'm not sure, but it's weird. But can we? Let's try it out and see if we can make it. So we're gonna have the printing, and when we parse these things. So wait, before this, let's add this code so we have a working part 1 solution. So now, what are we going to do? We're going to do something different than this. We're just going to ask if it is in the trench, and let's do it the other way around. This. If it's not in the trench, we are just going to push this. But if it is in the trench, we're going to push line, push stir, and we're gonna format. And actually, I'm going to copy from what was it, day 17? Yeah, here we did some terminal printing with colors, so I can steal the escape codes and the reset escape code also. So in here we're gonna do something like this. Format, we're gonna reference there, and okay, so what we are doing here is I think doing 11, then semicolon, then the hex code, and /a. I have no idea what it is. Like, this is probably mentioned here, right? /a. Terminal bell? What? Is this what I'm printing? And maybe it didn't sound? Maybe that's the case. But okay. So should be E close brackets 11 and that was it, right? No, 11 semicolon, and then not this but the hex color, and the hex color we need to parse. We are kind of parsing it, so we're just going to return it. In the input, however, they have parentheses, so let's get rid of the parentheses. Let's do hex color be hex color. We could strip the prefix and suffix, or we can just slice here hex color -1, something like that. Hex color length. and here I'm going to return the hex color, and this is going to be this. Are you happy with that? Yeah. Here we're going to have a hex color, and when digging, I guess we can put these hex colors here, right? Like, yeah, no problem with that. Now the hash sets should be this and strings. Beautiful. Then let's not care about digging the interior. Now this thing is asking if it contains this. Okay, so this doesn't work very well. I'm wondering if maybe I can change this quickly into a hash map or something like that. Or where should I put this information? Like the color for, yeah, no, let's just say this would be hash map, yeah, of this into string, and we are going to do it from an iterator of this, and the hex color of this, I don't know, we can maybe use white for this. How many Fs is that? Yeah, that's the correct amount of Fs. So are you happy with that? Now, your problem is mismatched types. Yeah, because this is a hash set, it should be a hash map. Okay, almost there. Here, this expects a key value, so the key is going to be this. The value is going to be the hex color. That's great. And now contains key. But what I want is basically to ask, hey, is there some hex color at trench get x and y? Is there? And then print it. Okay, let's see how this works. I somehow ran another different thing. This is what I wanted to run. Well, it's printed. It doesn't seem to have printed the trench, right? Where's the? What happened with the trench? Oh, it's not working in an interesting way. It's like printing nothing. Huh. So, am I missing? What am I missing? Like this printf, the escape A is I think we have to open the parents hexadecimal. I'm not sure about this. Without the escape code, without this mess, I should see the text of the hex colors being printed. And again, I don't know how I'm getting to. Yeah, so here, if we zoom in, we see that mess with the hex colors seem to be fine to me at least. So we should be seeing something when doing this, but the escape codes are like eating things. On the clumsy crucibles, I am wondering if the actual escape code should be something like this, and I don't understand what I'm seeing here. Although to be honest, I don't understand how any of these like ANSI escape codes work, but oh well. Here, what am I seeing? It's probably eating the first two or four of these digits, and this A, what are you complaining about this? Are not escape. Does this A do something? I don't think it does. Yeah, I'm not sure what's the print, this printf magic did here. It was setting the background, right? That's what it was setting, the background. Here if I search for 11 semicolon, and I don't find anything. Here 11 semicolon, also don't find things. There are other ways of doing this, like running commands to set the colors, but I'm not sure about this. Well, okay. It was a nice try, I guess, but let's forget about this colorful adventure. And yeah, for now, let's keep this solution for part 1, because for part 2, well, I think I'm not focused enough at this point. I can clean this up, I guess. Have to de-hard code the starting interior position for sure, but I mean, if for part 2 we're not going to be able to do fluid filling, because the numbers are pretty big, like we can see here in the example, where we are talking about like around 1 million or 500,000 for each instruction, and this was a pretty small thing, but already like 1 million times 1 million. Well, it's a billion, billón in Spanish, a trillion in English. That is, that's too big. That's what she said, and yeah, it's gonna be too big to fit in memory. So, and also to like process that. But yeah, but it doesn't fit in memory. That's the main thing. So we need to do something more clever, and I guess that's where we're going to need to do something like this shoelace formula, which also known as Gauss area. Again, Gauss doing everything. Awesome. Wow, it was described in the 70s. Not the 70s, that's 1700s. Sorry. Possibly oriented. Counterclockwise sequence of points. Actually, like knowing if the thing that we are drawing is clockwise or counterclockwise should be simple enough, because that's a matter of counting the rotations to the left and to the right, and then well, but you don't have the rotations directly, but well, you have the previous direction and then the next one, so you know, like, how are you rotating, and then you know, like, if it's a clockwise thing or a counterclockwise thing. And so xy, yeah, Cartesian coordinate system. For the simplicity of the formulas below, it's convenient to set p0 equal pn plus 1 equals to p1. Okay. Can be expressed by a variety of formulas. Trapezoid formula of oriented areas. Okay, this doesn't seem so horrible to implement. Yeah, and then the shoelace formula. Ooh, matrices. Where we have x1 and x2 and y1, y2. So I guess the shoelace is because you're like crisscrossing and like doing sort of a crossed product and adding all of those up. That's a very clever thing to realize, that it gives you an area. So yeah, I guess I will have to implement something like this for part 2. I'm glad that I was spoiled about this. Otherwise, I wouldn't know really where to start. Maybe do some triangulation of the whole thing, or like tessellation. Yeah, I would probably try to, let's look at the shape of this thing. That's not printing. Did I remove this? I can leave this under probably a environment variable. So if env var, let me import this. Yeah, debug is something. We're gonna do this. So now we can here run this with debug 1, I guess. Yeah. And okay, we have this sort of thing. Like, maybe what I would try to do, well, it's not going to be the same shape with the hex color interpretation of coordinates, but it will do something similar to this, I guess, and this could be like tessellated or cut into rectangles, but doing that seems also pretty daunting. Like, I also wouldn't know really where to start. Maybe I would know, like, you could do like scan lines and from left to right, and trying to like say, okay, I'm going to get this rectangle. Like, whenever the maximum and minimum changes, is like you cut rectangles, basically slices of rectangles. But it's not it's definitely not a trivial thing to do. So I think I'm going to try to go for this shoelace formula. But well, I will read about this off video and probably come back to this problem tomorrow, because today my brain is a bit toasted. So I think this video won't need a special thumbnail, because this already looks like a thumbnail to me. And as usual, if you have been watching, thanks for doing so, or thanks for watching, and see you later. Bye bye.